Good morning, students. I welcome you again to the chemistry lecture. And the class of chemistry is going on, and we are doing atomic structure. The atomic structure is from a physical chemistry. Chemistry is usually divided into three branches: physical chemistry, organic chemistry, and inorganic chemistry. So, what we are doing? Physical chemistry. Which chapter we are doing? Second chapter, that is the atomic structure. In our last lecture, if you remember, I told you a number of things about absorption and emission spectrum. So today I am going to take you back into the models of atom. As you remember that we have done Thomson atomic model of atom, we have done Rutherford atomic model of atom. So now, with regard to, in reference to Rutherford atomic model, we will study that whether Rutherford atomic model was successful till date. Is it successful till date, or was it discarded due to certain drawbacks? So definitely Rutherford model was discarded. Actually, Rutherford thought that in an atom the nucleus is present in the center and electrons are revolving around it. So he considered an atom with reference to the solar system. But as you know, in a solar system, all planets have their mass of their own. They are very heavy. So there are no chances that they are going to change their direction, they are going to change their path. So they will be constantly rotating in their orbit. But if we talk about electron, as you know, the mass of an electron is negligible. So Maxwell, he came out with a very important observation which discarded Rutherford model. Maxwell gave an assumption. He said, if electrons are revolving around the nucleus, then they must be losing energy, and that energy must be getting lost in the form of electromagnetic radiations. So finally, according to him, in 10 raised to the power minus 8 seconds, every electron which is revolving around the nucleus must lose energy and finally fall into the nucleus. So nothing happened like that. Even atom is stable. So Rutherford model of atom was unable to explain the stability of an atom. He was unable to explain that how atom is stabilizing, how electrons are still maintaining their position, how electrons are getting exchanged from one energy level to another energy level. So we can say Rutherford model of atom could not explain the stability of an atom and line spectrum of atom. This was the one of the serious drawback of Rutherford model of atom. Okay, and even it was unable to explain the structure of atom. What kind of structure atom has? So beta, as you can see, the diagram is still there. According to Rutherford model of atom, nucleus is there, an electron is revolving around the nucleus, but it is also continuously losing energy. So if we follow Rutherford model of atom, then electron must fall into the nucleus, which is not happening, and it never happens. So due to this reason, Rutherford model of atom was also discarded. Now, to understand proper structure of atom, that how electrons are positioned in an atom, what is the position of the nucleus, new concept was given by Niels Bohr. He was a Danish physicist. In 1913, he proposed a model of atom, and this model was based upon the Planck's quantum theory of radiation. Remember, we have done Planck's quantum theory. According to Planck quantum theory, the energy is absorbed or emitted in the form of small packets. These small packets are known as photon and quantum. Yani small packets of energy are known as photons. So on that basis, Bohr model of atom came into existence. You all know the Bohr model of atom very clearly, because in the starting itself I have explained to you that and in an atom there are number of shell. So number of shells, I have given you magic number also, that is K is the innermost shell. Okay, let me zoom it for you. K is the innermost shell, then comes the L, then comes the N, and then finally N. K, L, M, N. And the magic number is 2, 8, 8, 18. Now, he gave number of postulates. The first postulate was an atom consists of small, heavy, positive charge nucleus in the center, as you can see. Nucleus is in the center and electrons are revolving around the nucleus in an orbit. And what are these orbits? These orbits, beta, are those circular energy levels which have same or definite energy. They always possess definite energy. Number 2, the energy of an electron in orbit does not change with time. Okay, so suppose if electron is revolving in a K shell, its energy will be same. If an electron is revolving in M shell, it will have the same energy. Okay, K shell will have one type of energy, L shell will have higher energy, M shell will have more higher energy, N shell will have more highest energy. Okay, so the third one is angular momentum concept. According to this concept, there is a quantization of energy, that is, according to Rutherford, if we consider angular momentum, that is MVR, it is always equal to whole number multiple of h over 4 pi. That is, MVR should be equal to n h over 4 pi, where h over 4 pi is angular momentum. So angular momentum should be always quantized, means energy can never increase or decrease in a particular energy shell. Now came the fourth point. According to fourth point, an electron can easily absorb energy or emit energy. Okay, beta. So if electron absorbs energy, it will jump from lower energy level to higher energy level. Okay, and when electron jumps from lower energy level to higher energy level, this energy level is known as excited state. Suppose electron is in K shell. It absorbs energy from the environment and it jumps to N shell. So when this electron of K shell jumps to N shell, such state of an electron is known as excited state. Okay, and again this electron which has gone to the excited state, it can again lose energy and come back to the lower ground state. So going towards the excited state and coming back to the normal state is possible. If electron absorbs energy, it will go to the excited state. In the excited state, if the electron loses energy, it will come back to the ground state. So the energy difference can be calculated very easily, that is delta E, that is total energy, that is equal to E2 minus E1, where E1 and E2 are energy of two energy levels, that is ground state and excited energy state, and delta E will be the difference in energy of two levels. So this was the Bohr model of atom, and it was accepted for a very long time because it was having minimum drawbacks. Okay, so let me revise all the postulates to you. The first one, atom consists of a nucleus center in the center, and it contains number of shells in which electron revolves. No, don't do that. The energy of electrons remains constant, and then quantization of angular momentum, and then electron can absorb energy, can move to higher excited state and come back to the ground state. And that energy difference can be calculated by E1 minus E2, whereas E1 and E2 are energy of two different energy levels. So I hope you are understanding what I am saying. So I'll give you one more diagram which will further explain this to you. See, this is the nucleus. Energy is absorbed by this electron. After this, the electron will jump to the higher energy level. Okay, and again this higher energy level carrier, that is the electron with higher energy, can again lose energy. Energy can come out, that is emit, and then it can come back to its ground state. So whenever electron is present in its original energy level, it is known as ground state. When electron jumps to higher energy level, it is known as excited state. Now let's study why Bohr model of atom was a success due to certain number of reasons. सबसे पहले, number one, Bohr atomic model explained stability of atom. He was able to explain stability of atom. Earlier, Rutherford, Maxwell, they were unable to explain how atom was stabilized. They were thinking if the electrons are revolving and they are losing energy in the form of electromagnetic wave, they must fall into the nucleus. But according to Bohr model of atom, we were able to understand the stability of atom. How he explained the stability of atom? He explained the stability of atom on the basis of shell system, orbit system. He said there is a nucleus in the center and electrons are revolving around the nucleus, and they are revolving in a well-defined orbits. And what is an orbit? It is a two-dimensional circular path around the nucleus in which electron revolves. So he was kind of able to explain all the characteristic of an atom. The first thing he resolved was he explained stability of an atom. Okay, he explained how electron stays stable, how electron revolves around the atom. It was a new concept to the world. So Bohr revolutionized this atomic model concept. Next, number two, Bohr model of atom was unable to explain atomic spectrum of hydrogen. So beta, in our next lecture, when we will meet, when I will send you the next lecture, I will tell you hydrogen spectrum, how Bohr was able to explain it. So don't worry, okay? These are the two main success of Bohr model. And after this, there were again drawbacks of Bohr model also, but we will study the drawbacks in the next time. So I have this hydrogen spectrum, and I want to explain it to you today only. So just listen to me more intensely, okay? So बच्चों, this is a hydrogen spectrum. Don't worry, it is very easy to understand. Very easy to understand. Okay. Suppose an electron can be present in any shell. You know, hydrogen atomic number 1, it has one electron. Suppose this is the K shell, this is L, M and O. These shells are arranged on the basis of their increasing energies. When electron from O shell jumps directly to an K shell, that is the first shell. When electron from, I'll simplify it for you. When electron from any shell rather than K shell, when electron from O shell, N shell, M shell, L shell jumps to K shell, that is the first shell, that is known as Lyman series. Those lines in which electron jumps from higher energy level to the K shell. See, in first case it's jumping back to K shell from O. Another one, next one, it's jumping, it jumps from N to O, N to K, and next one it jumps from M to K, and in the last one it jumps from L to K. So when electron jumps from higher energy level to K shell, it is known as Lyman series. The lines which we obtain are known as Lyman series. And when electrons from higher energy level jumps to second shell, it is known as Balmer series. And when electron from multiple higher energies jumps to third, it is known as Paschen. And when it jumps from higher energy to fourth, it is known as Bracket. And when it jumps from higher energy to N shell, it is known as Pfund series. So all these lines which we are obtaining here, they give rise to hydrogen spectrum. So in hydrogen spectrum, there is only one electron which is jumping from various energy levels to another ground levels. So in first case we have considered K shell as the ground level and other shells as excited. Similarly, in second situation we have considered L as the ground level, so on, M as ground level, so on. So whenever electron jumps from excited state to ground state, it give rise to number of lines, and these lines are known as spectrum. So this is the hydrogen spectrum. Okay, so every atom have different spectrum because they have different energy level. Energy spectrums can never be same for two different atoms. They are always different because electronic environment, nuclear environment are different for different atoms. So bachcho, this was my today's lecture. I hope you understood what I taught you. What we did: drawback of Rutherford model, we did Bohr atomic model, we did its postulates. I have explained every postulate to you. After that, I explained hydrogen spectrum to you. Okay, so now what you have to do, I'm going to send you this hydrogen spectrum. Draw it very nicely, use multiple colors, and if possible post it in the group. So you have to post it in the group so that I can I may come to know that whether you are working or not. So whatever assignment we are giving you, whatever test we are giving you, you have to study better. You have to reply, you have to respond, because all these activities we are recording, who is doing, who is not doing, and finally it will affect your CCE assessment, and on that basis you will get your marks. So soon schools are going to start very soon. Till then, whatever work we are giving you, take those work very strictly and seriously. So it's and for now, best of luck, stay safe, stay home, study hard.